All right.
I'm ready whenever you are.
Go ahead.
All right, so continuing off what they discussed in the first two parts of the video, we have attached all of our calculations, theoretical and measured values, in our PowerPoint slide that these videos will be inside. One of the things we found out when we go into the problems and modifications, a big concept we had to overcome was the idea of an ideal power source versus a non-ideal power source. Initially, we were making all of our theoretical calculations based on the fact that our circuit was receiving 20 milliamps of current. However, when we actually ran the circuit together, we found that that wasn't the case, and that we were actually only getting roughly about 13 to 14 milliamps. We basically discovered that our current was being affected by the overall Thevenin resistance. We weren't necessarily keeping account the amount of resistance that was being supplied by the LEDs and from the DPT switch and the source, the resistance of the source itself. When we calculated that Thevenin resistance and we compared that with our Thevenin voltage, we found that our actual current source, the current through the circuit, was 13.7 milliamps, so right in our expected one. After that, we did all of the calculations to essentially prove that our measured versus theoretical were within acceptable ranges. One other problem that we ran into in our initial design was the use of a MOSFET. Essentially, it acts as a gate. However, the analysis for MOSFETs within our circuit was outside of our current scope. Now, it is something we could use in the future as we learn more about the concept. The use of MOSFETs could be placed in several locations in our circuit to replace the DPT switch and make it more automated.